Welcome, Wildcats. Today we're looking at Monday, October 31st, factoring polynomials. And that's going to be on a very scary page 28. Okay, so if you would, pause your video and update your table of contents. All right. So let's look at our notes. All right. So today we're looking at factoring polynomials. So the factoring polynomial steps are: step 1, find the greatest common factor, known as the GCF. Now a note, if you have a trinomial ax squared plus bx plus c, then factor if possible. Notice I said if because some trinomials are not factorable. All right, step 2, factor ax squared plus bx plus c. So we do this by, I like to call reverse box method, because you multiply polynomials to get, or multiply to get ax squared plus bx, but now we're doing factoring, which I think is like reverse, okay? All right, so what you do is you take ax squared and c and put them in the box, okay? Now you have to ask yourself is what terms multiply to give you ax squared? Then once you have that, then you ask yourself what terms multiply to give you c, but combine to be bx, okay? So if you would, update your notes. All right, let's look at our examples. All right, now I'm going to do something different today. Okay, I'm going to go through all the examples, but I want you to do is, if you get stuck on one or you didn't understand my explanation, circle it and then ask me to go back over it in class, okay? All right, so let's look at example 1. So first things first, we find the greatest common factor. Well, to do that, well, is there a term that factors from 6x squared and negative 15x? Well, to answer that, it is 3x. Okay, and the reason being is 3x times 2x. So 3x times 2x is 6x squared. So we factored out a 3x from 6x squared, and 3x times negative 5 gives you negative 15x. So the greatest common factor is 3x, because we could divide a 3x out of 6x squared and negative 15x. So, and to show you, 3x times 2x is 6x squared, and 3x times negative 5 is negative 15x. Where negative 16x squared divided by 3x is 2x, and negative 15x divided by 3x is negative 5. All right, so now we've factored out the greatest common factor. Now we notice it's not a trinomial, so this is in complete factored form. So we stop here. All right, let's look at example 2. So the greatest common factor is 1. So now we move on to factoring. It's a trinomial, so we draw our box. So x squared, I'm going to put a 1, 1x squared and 6. And the reason why we step back, the greatest common factor is 1, because the only number that we can divide out or factor out of each of these is 1. Okay? All right, so now we're looking for what term multiplies to give you 1x squared. And the only option is 1x times 1x. Now the next is we need to find out what multiplies to give you 6, but combines to be negative 5x. Well, to do that first is let's find all the combinations that give you 6. And we know that both have to be negative because a negative times a negative is a positive and the middle term is negative. So we know that negative 1 times negative 6 equals positive 6. But we ask ourselves, does negative 1 combined with negative 6 give you negative 5? And the answer is no. So now let's try the next combination, negative 2 times negative 3. Well, negative 2 times negative 3 is a positive 6. Then we ask ourselves, does negative 2 combined with negative 3 give you negative 5? And the answer is yes. So our two terms here are negative 2 and negative 3. So 1x times negative 2 is negative 2x, and negative 3 times 1x is negative 3x. Negative 3 times negative 2 is a positive 6. So we have these combined to be negative 5x, so we factored it. So in factored form, you have 1x minus 2 times 1x minus 3. Okay? All right. So let's look at example 3. All right, so example 3. The greatest common factor. Now, this is a special case. You can't have, when factoring, a negative 1 in front of the x squared. So your greatest common factor in this case is going to be negative 1 because we have to factor out a negative 1. We always want a positive number in front of x squared. So our greatest common factor is negative 1. So our trinomial becomes negative 1 times 1x squared minus 3x minus 4. And the reason being is negative 1 divided by negative 1 is a positive 1, positive 3 divided by negative 1 is a negative 3, and positive 4 divided by negative 1 is negative 4. And you can always check. Negative 1 times 1x squared is negative 1x squared. Negative 1 times positive 3 is a negative, or negative 1 times a negative 3 is a positive 3. Negative 1 times a negative 4 is a positive 4. All right, so now we factor. So we draw a box. Now we're not going to worry about the negative 1 at the time. We're only worried about here. So 1x squared and negative 4. So we're looking for what term multiply to give you 1x squared. Well, 1x times 1x. Now the next thing we're doing is we're looking for the terms that multiply to give you negative 4 and combine to be negative 3x. So let's write out all the combinations that give us negative 4. So we know negative 1 times 4 is negative 4. Well, combine these. Does negative 1 combined with 4 give you a negative 3? And the answer is no. So then we try negative 2 times 2, which we know is negative 4. And then you ask yourself, do these combine to give you negative 3? The answer is no. So we know negative 3 doesn't work because negative 3 times nothing will give you 4, so that's out. And then we go to negative 4. Negative 4 times 1 is negative 4. Well, we get negative 4 when we multiply it, so now we ask ourselves, do these combine to give you negative 3? And the answer is yes. So you have x minus 4 and x plus 1. And so 1x times negative 4 is negative 4x. 1 times 1x is 1x. So we combine terms, gives us negative 3x. These multiply to give you negative 4. So we are done. It's factored. And we want to bring back the negative 1, the greatest common factor. So negative 1 times 1x minus 4 times 1x plus 1. All right, so let's look at example 4. All right, so example 4, we look for the greatest common factor. In this case, it is 1. The only thing that we can divide out of each term is 1. So then we draw our box. All right, we have a trinomial, so we're going to factor now. And again, we're looking for, we put 2x squared, 3. So we look at what terms multiply to give you 2x squared. Well, we know that 2x times 1x. Now we know that we're looking for what numbers multiply to give you 3 and combine to be 7x. So we look at all the combinations that multiply to give you 3. So that's 1 times 3 equals 3, and 3 times 1 equals 3. So our only combinations are 1 and 3 and 1. So let's try 1 here and 3 here. So 2x times 1 is 2x. 3 times 1x is 3x. Well, these don't combine to be 7x, so we know that that combination doesn't work. So we'll try this. We'll try plus 3 and plus 1. So 2x times 3x is 6x. 1x times 1x is 1x. 6x and 1x combine to be 7x. 1 times 3 is 3. So we now know it is factored. So we have 1x plus 3 times 2x plus 1. Now you're probably, as you're working this, probably asking yourself, isn't factoring fun? And it is. It's a perfect assignment for Halloween because you're probably getting scared right now, and everyone likes scary things on Halloween. All right, so example 5. Greatest common factor. Well, the greatest common factor is 1 because the only thing we can divide out of each of these terms is 1. So now we factor, we're going to draw a box. All right, so 1x squared, 25. All right, so we ask ourselves, what terms do you multiply to give you 1x squared? So the answer to that is 1x and 1x. Now, at this point, I want you to pause for a minute. I want you to try and see if you can finish example 5 on your own. All right, so I'm assuming if you're watching this now that you've paused, you've tried this on your own, and that you're now watching me to see if you got the correct answer. So now we ask ourselves, what terms multiply to give you 25 and combine to be 10x? Well, let's look at all the combinations that give us 25. So 1 times 25 is 25. But then we ask ourselves, does this combine to give you 10? The answer is no. So then we try 2 doesn't work, 3 doesn't work, 4 doesn't work, 5. 5 times 5 equals 25. And then you ask yourself, well, 5 times 5 is 25. Does the combination of 5 and 5 give you 10? The answer is yes. So we have 1x plus 5 and 1x plus 5. So 1x times 5 is 5x. 5 times 1x is 5x. So our factored form is x plus 5 times x plus 5, which if you want, you could write as x plus 5 squared. All right, let's look at example 9. All right, so we look for the greatest common factor, which we know is 1 because the only term that number we can divide by both numbers is 1. Factor out is 1. So now you're probably asking yourself, this looks different. This isn't a trinomial, Mr. Luke. What are you doing? So I want you to pause for a few seconds and think, what can I do to make this a trinomial? All right, so I'm hoping you paused, you thought about it, maybe went trick-or-treating. Now you're back, you got some candy, and you've come to the realization that I can write this as 9x squared plus 0x minus 4. Okay, we've now manipulated this binomial to make it a trinomial because we know 0 times x is 0. Okay, so now we're going to draw our box. All right, so now 9x squared and negative 4. All right, so then you ask yourself, what do you multiply to give you 9x squared? Well, you have two options. You have 1x, 9x, and 3x and 3x. Okay? Now, so then you want 0x. Okay? So then you find the combination that gives you negative 4. Well, we know that negative 1 times 4 gives you negative 4. We know negative 2 times 2 gives you negative 4. And negative 4 times 1 gives you negative 4. And this is all great, but here's the problem. If these are going to become 0x, they're probably going to be the same term. So 1x and 9x probably isn't going to be a good idea, and this isn't going to be a good idea. So let's try 3x and 3x. You might ask yourself, well, why, Mr. 3x and x? Well, let's watch. Now, I erased the combination of negative 4, but I'm going to rewrite those because actually these are still okay. Negative 2 times 2 and negative 4 times 1. All right, so let's try a combination. So we need these to cancel. So 3 times negative 3 and 3 times 4, so that'd be 12 minus 4. That's not going to cancel. 3 times negative 3 is negative 6. 3 times 3 is 6. Negative 6 plus 6 becomes 0. So let's try this. Let's try minus 2 and plus 2. And the reason why I picked those is this is the only combination that would become 0. Okay? So 3x times 2 is negative 6x. 2 times 3 is 6x. So these combine to be 0x. This multiplied to give you negative 4. So we've now factored 3x minus 2 times 3x plus 2. All right, so let's look at example 7. And actually, I think you've probably had enough factoring for the time. So let me go over example 7 and 8 in class. But again, I'll also go over all of these again in class, or just any ones. If you want me to go back over example 1, 2, 3, 4, 5 or 6, again, by all means, please let me know and I'll go back over them. Especially I can understand example 6. That was probably a little bit confusing. So, with that, Wildcats, assemble.